Welcome to our tutorial on how to do a rotational analysis on a Cine file. So the first thing I'm going to do is upload a Phantom Cine file, and I chose to analyze a fan blade. A fan is nice because it will rotate about a fixed axis in time. And here we have strategically placed markers all over the fan, together with the speckled pattern here. So we have the luxury of selecting one of these markers or two of these markers and using them to extract some rotational information from this subject. So the first thing I'm going to do is I'll choose the two inner circle markers to track versus time. So I'm going to go ahead and click track, and I'm going to add an object. Okay, and I'm going to go ahead and hold Control and use my arrow keys to drop a marker right roughly in the center of that circle marker. I'm going to right click the object and edit the name of it, and I'll call it circle 1. Click enter. I'm going to add another object here. I'm going to hold Control, use my arrow keys, and drop it, Control enter, right in the center of that circle marker. I'm going to go ahead and edit that name and call it circle 2. Okay, and I'm going to go ahead and right click on the first marker and click on the auto track dialog. And I noticed that my template images, which are the colored boxes here, which represent the actual image I'm going to go ahead and track, are a bit small relative to my template box. So I'm going to go ahead and increase the size by 10 pixels. And I can see in real time that my red box has gotten bigger. I'm going to apply this to both of the subjects, and you can see that the orange box also got much bigger here. All right. And since I have this speckle pattern on the periphery of my circle marker, as my templates rotate in time, what's going to happen is my template image is technically going to change to some degree, right? So I'm going to loosen up on my auto tracking criteria. I'm going to say an acceptable score is 60%. If it's less than 60, it'll break the track. If it's better than 60, it will keep the track. For the purposes of this tracking, we could certainly use sub-pixel tracking, but we'll keep it at 1 pixel just for speed. Okay. And then I'm not going to go ahead and update the template. All right. And I'm going to go ahead, apply all of the settings to both of the template images. And to process both of these markers, I'm going to go ahead and click process all. All right. All right. So you see it churning away here. So it looks like I indeed got a nice track of my subject. I'm going to close that, and I'm going to go ahead and scroll across to see how we did. All right. So looks like we got a good track here. Purely from just an observational standpoint, you can immediately take a look at this. And if you wanted to get roughly the frequency of rotation here, you could take a look at the displacement versus time for each of these graphs, and you could take a look at it's taking how long to repeat its cycle here. So here, if I look, this is around 0.05, so I would say 0.04, maybe let's say 2 or 3 for the repeat. That would be my period. So I can immediately say 1 over 0.043 is roughly my rotational rate, provided it's a constant speed of the blade, which is a nice way, right? So you could certainly take this data and use it like that. We also have a really nice feature if you click the drop down here, and it looks like it's dropping down below the view window. One of the selectors here is the X vibration and Y vibration. If I click on X vibration, I basically am taking the path of the markers moving in only the x direction, for example, okay? And I'm doing a discrete Fourier transform on that path, okay? So what that is it's essentially putting this path in a frequency domain, which will also give us our frequency in the x direction and in the y. So if I want to take a closer look at this, I can go ahead and click on the pop-out button. I can draw a window zoom to see really where all this data is. And this automatically plots or marks off the peaks. So here we have a nice strong peak at around 24 hertz, which is consistent with the observational data we saw from our initial displacement plots. So that's really good. We can go ahead and export this data if we wanted to. Let's go ahead and take a look at our Y vibration, which is the path analyzed in the Y direction. That should give us consistent data here. So if we click on that, we see we get the same exact frequency of the rotation here. So that's great, 24 hertz. So that's a really convenient way to get your rotational rate across a constant system here. Another nice way to get your rotational velocity is to use the 3-point tool. So if I click on the 3-point tool, what I can go ahead and do now is I can click on a marker on the periphery here. So I'll hold down Control and select this marker's center, okay? Then I'll click on the central axis of this fan. I'm gonna approximate it here since I don't have a well-marked axis. I'm gonna click Enter. And then what I'm gonna do is I'm gonna progress a few frames forward, okay? And I'm gonna click that same point again. So I'm gonna go ahead and use my control keys, arrow, and click Enter. And the output is here in the green text. Between the frames that I select, I progress through. So I put my first marker at the 0th frame, and then I moved 12 frames forward. I let it progress around 15 degrees, and I was able to compute that this subject is moving at an angular rate of around 7949.62 degrees per second. Okay, so this gives you a really nice data point for what kind of speed your fan blade is rotating. All right, so those are a couple really neat tools that you could use with a Cine Analyzer to extract the rotational rate of a fixed axis subject. I hope you enjoyed this tutorial. I'm looking forward to the next. Thanks.